So example one looks at exact values. And with exact values, we need to know our special triangles. So our two stressful triangles are our 45-degree triangle, okay, which has a 1, 1, √2 ratio. And then we also have our 30-60 triangle. You draw that. Okay, our 30-60 triangle is going to be a little bit taller and thinner. Okay, so our 30-60 triangle has a ratio of 1, 2, and √3. Okay, so first of all, we have to identify the location of these angles. So sine of -5π/4, it's the red angle here where we go backwards. We're going backwards in this direction. Okay, and we're going to end up in quadrant 2. Now, the second thing we want to do is, first thing is identify the location of that angle. So I know I'm in quadrant 2. Okay, and that's the point in quadrant 2 that I'm going to end up at. The second thing is we need to identify the triangle that we're working with. In this case here, we're dealing with the 45-degree triangle, this one here. So our ratios are going to be -1 along the horizontal, +1 along the vertical, and √2 along the radius. So when we take a look at the sine ratios, sine is vertical, so it's going to be 1 over square root 2, and that's our exact value. For secant, again, we need to, 7π/6, we need to locate the position of 7π/6. So 7π/6 ends up in this position right there. And when we go positive 7π/6, we're going to rotate from 0 in this direction. Okay? So that's the location. So that's the first thing. Secondly, we need to identify the triangle. In this case, we're dealing with the 30-60 triangle here. So the ratios of those, the 30-60 triangle are going to be, it's going to be 2 along the hypotenuse, or the radius. It's going to be -1 down, and that's going to be -√3 to the left. So for secant is a reciprocal of cos. So cosine is horizontal. Cosine would be -√3/2. So for secant, we're just going to flip that fraction. So instead of -√3/2, we're going to do 2 over -√3. Okay, and we can put that negative either in the front or the top. It doesn't really matter. For converting 130 degrees into radians, we need to use our conversion factor. So the conversion factor is pi radians for 180 degrees. And we can just use this as a multiplier and go 130 degrees times, and we can see that the degrees are going to cancel out here. And we're going to end up with 13 pi over 18. Now we don't need to leave this in terms of pi. We can just put this into our calculator, and we get a value of 13 pi divided by 18. 13 pi divided by 18 gives us a decimal value of approximately 2.268. So I'm going to round that to 27, and that's in radians.